Today we want to practice solving some right triangles, so I have some problems for you to work on. I've written the toolkit up at the top. I've also got the toolkit over here. We're about to break into groups like we normally do. You've got cards. The boards are labeled. There's a pen at each of the boards. So we're going to work on these problems. The things that I'm interested in is that I just asked you to find the three other things. I didn't specify some order that you need to find those things. So I'm interested in did you all find the same things in the same order, right? So how high of mind are we going about these problems? Did we all just do them in the same order? If you did things in a different order, what changed? And while you're thinking about the order of the three things that you need to find in solving a right triangle, while you're thinking about the order of the things that you need to find, or the order that you find the things that you need to find, that sentence is just going to be a trash sentence all the way around. As you're thinking about the order of doing things, is there always a way to avoid using rounded information? Remember, using rounded information is okay as long as we don't round it early. Just got to make sure that our calculator is using all those digits, even if we're only going to write down 3 of them. So is it always, can we always avoid using rounded information? With that in mind, let's break into groups according to your card like we do. And I'll give you some time to work on these problems, or at least discuss the problems that you've already been working on. Let me briefly go over some of the observations I made while observing all y'all's work. First off, in the first problem, I think this is actually the example that I did yesterday, so I guess I'm not very creative in coming up with triangles. So, but there it is. Almost everybody, it looks like everybody was like, I've got one of the angles, I'll subtract to find the other angle. So that's good. You go for the easiest thing first. I got one angle, I'll just immediately subtract and find the other angle. If you didn't, that's totally okay. My particular way of doing this problem, I just took the 37 and then the 6.4 and I remixed it with tangent to find B and sine to find C. We didn't have to do it that way. That's just what occurred to me to do. The best thing to do is whatever occurs to you to do first. Best thing to do first is whatever occurs to you to do first. That's your instincts developing. That's your habits developing. That's what we want to have happen. So I also like this because I'm solving for the thing in the denominator, and I want to use that cool division thing where we just flip those two around. So if tangent is 6.4 over B, then B is 6.4 over tangent. 3 is 6 divided by 2, so 2 is 6 divided by 3. I don't know if that works for everybody. That's just the way things go in my mind. You might fill it in with different letters. So if A is B divided by C, then C is B divided by A. So however, that's going to you're going to get from one equation to the other equation with the thing that you want isolated. That's what you need to do. I also said 3 significant figures, and I didn't put 3 significant figures for B. No one called me on it, so that's minus 1,000 points for everybody. Once we had the side 8.49, we could go back and use that in the Pythagorean theorem. We could be like, oh, no, we are all about the Pythagorean theorem. I've got 2 sides. I'll use the Pythagorean theorem to find the third side. The most important thing to do if you're going to do that is not to round this off to 8.5 and then do the calculation. Keep all the digits that are on your calculator so that you don't, and just round it off to the 10.6. It might be fine. It might not. We're going to be careful. In problem B, the difference in triangle B is that I did not tell you one of the angles, so we couldn't subtract to find the third angle. So we had lots of options here. That's great news. We got lots of options about how to proceed. That's terrible news. We got lots of options about how to proceed. So I chose to do angle A first because I got to use my new shiny trig functions. Some of you did the Pythagorean theorem first. Who's on Pythagorean theorem first? That was like the most recognizable thing. If I had to bet, that was going to be the most common one. Yeah, I think no real notes on problem B. Any questions? Is everybody okay? Everybody looks so stoked. You look like this. Yes, I'm gonna make fun of you all semester for giving me the blank stare. And no, I am not gonna play poker with any of you. Because we'll be sitting at the poker table, you'll make a bet, and I'll be watching you, and you'll look at me like this. And I won't know what cards you have. I do want to talk about this third problem, this third triangle, which is not actually a triangle at all. One thing that we want to notice, we might notice right away that the hypotenuse is 5.3 and that side B is 9.4. And so we recognize right away, this is not a triangle. I don't know why I'm shouting it, but I tend to shout everything because it's in the afternoon. We're almost done, and so I'm like. So this is no triangle. We might notice right away that this is no triangle. This is unacceptable. The hypotenuse must be the largest side. So immediately the ruling on the field is no triangle. Need to be familiar with that. The referee will make a triangle and then shake his head back and forth. This is the referee symbol for no triangle. You stand out there, you do this. That's the referee symbol for no triangle. It doesn't come up that often in modern American football. It used to happen all the time. What we want to do, the reason that I put this one on there is that we want to recognize when this happens if we don't notice, because we won't always notice, and we don't want to sit there and think, is this possibly not a triangle? So we don't want that in our minds all the time. We want to know when our calculator is trying to tell us there might not be a triangle. So what if we don't notice? So the thing that I want to do with this problem is think, what if we don't notice that there's no triangle here? There's a few things that we could do. One of the things that we might do is say, I've got two sides. I want to find the third side. So we might say a squared plus b squared is c squared. We might notice at this point, we're about to subtract and get a negative number for a squared, and that's not okay. Real numbers don't have squares that are negative. A few things might happen. If your calculator is in real mode, then when you try to do the square roots of 5.3 squared minus 9.4 squared, it's going to tell you that there's a non-real answer. It says error, non-real answer. Because we're trying to find the square root of a negative number. And that's not real. Your calculator can cope with non-real numbers. So if we just hit enter and our calculator is in complex number mode, then it's going to give us this 7.76. And the problem is we're missing the important part of this number. This is not a 7.76 because at the end there's a little I. You see it? This is not a real number. This is an imaginary number. I is the square root of -1. That's bad grammar. I am the square root of -1. So this is a complex number and it's hard to spot on our calculator. So if you don't want that to happen, make sure your calculator is in real mode. And then it'll tell you that you got a non-real answer instead of hiding it with that little tiny I. I'm actually not sure what your phone calculator does. Does it just say error? I don't think we have like. If I put in -1 and then square root it. Now, it's important to recognize that error means there isn't a triangle, like in this case, or you didn't type the numbers right. So make sure you go back and check your calculations. Check what you typed on your calculating machine. The other way we would get an error is if we try to say this is adjacent and C is hypotenuse. So we could say sine of A is adjacent over hypotenuse. We still haven't noticed that this can't work because we can't have this be bigger than 1. And then so A is sine inverse of 9.4 over 5.3. And the same thing will happen, or actually a slightly different thing will happen. We'll get an error, but a different kind. So in this case, we're getting a domain error. The sine inverse can't, there is no angle that has a sine of more than 1. 9.4 divided by 5.3 is more than 1. This happened on evaluating trigonometric functions when I said solve sine of x equals 2.13. 9.4 divided by 5.3 is more than 1. This can't be because the adjacent side has to be smaller than the hypotenuse. So the ratio of adjacent divided by hypotenuse has to be less than 1. So if you're getting errors on your calculator, that might mean you're typing things in incorrectly. Type it again. Check your numbers, type it again. Or it might mean that there is no triangle. Any questions? Comments? Yes. Cosine. Thank you. I'll edit that out to make sure, make it look like I didn't make a mistake. I'm just kidding. I'm not going to edit my video. Any questions? Comment? Not a little. This is what one of the pages on the practice test next week will look like. It'll have the same opening. I don't know if I want to do this problem 1 or problem 2. Probably problem 2 because that's the order that we encountered them in class. So it'll be in problem 2. I'll still have the same 3 things at the front, and there'll be 3 different triangles. And I'm asking for all the parts. You have to decide what order you're going to solve things in. I might cut it down to 2. I'm probably not going to put a non-triangle on there. Just because when I do, everybody walks up, it's like, well, is it possible that there's not a triangle? And I feel like, well, I don't know. Is it possible that there's not a triangle? And then it's really annoying for you. It's funny for me. I'm like, I don't know. Is it possible there's not a triangle? But then you're like really pissed at me. And so I don't want that to happen. So it might just be 2. Any questions? Comments? Snide remarks? All right. That's going to do it for today. That's going to do it for this week. I will see you all on Tuesday. Everybody have a good weekend. And thanks for playing.